Alright, so in this video I'm going to show you how can we present the data into Excel with graphs. First of all, you need to make sure you know what your experiment is about. For example, in this experiment, the independent variable is S, which is the displacement along an incline. Dependent variable is time taken for the ball rolling down the incline. And there are some control variables as well. They can be the angle of inclination, which is the theta, mass of the ball, surface conditions of the incline and the ball. Okay, and the last, you need to know your rationale. That will tell you what measurement you need to get from your data. Okay, and the rationale is from certain research, for example, from the Harvard University websites. You can have that result for a ball rolling down an incline its acceleration equals a 1.43 over 2 times g times sine theta. So theta is the angle incline, g is 9.81. Right? So that's the thing. Yeah, you need to have the variables and also you need to have a target. Your target is to measure acceleration by using the displacement and the time taken. Okay, let's have a look what measurements this group did in their experiments. First, they measure the angle or the sine theta, which is 10 over 100, which is 0.1. Okay, so that measurement is useful. That means they can substitute that sine theta with 0.1, then they will eventually have a theoretical value of A, but we can get that later. And also for in the case of sphere, they've done 3 tests for each displacement, and for each test they have calculated the average, also the absolute the uncertainty of absolute uncertainty of mean. Okay, and they also have percentage uncertainty. All right, so let's see would this kind of data useful for their research. So the displacement is S. Let's use the average time as T. And we need to establish a relationship between S and T. So there are plenty of formula. The first formula you might think of is this one, right? Okay, so in this experiment, the initial velocity is is U, and the final velocity is V. Alright, so would that relationship work? Okay, so let's think about this. You have S and T. So these two are going to be measured. So this would be your independent variable. So that would be your X. That would be a Y. Is that V a constant? No. V actually depends on V is the final speed, which depends on S and T. So V is not a constant in these experiments. So this relationship is not helpful. So we are not going to use this relationship. How about the second relationship between S and T? So another formula, S equals UT plus half AT squared. Wait a minute, I need to check my video. Hello? Yeah, it's working. Sorry for. So S equals UT plus half AT squared. Let's think about this. and U is 0, so which is good. And A, okay, we need to check whether that A is that thing, but that's from the rationale. This is the theoretical result. But we understand A should be a constant. So you have your X value and you have your Y value here, and the other are constant. So this is the relationship we want to use. Okay. So let's see how can we construct the relationship in a Excel. So what kinds of variables are going to be useful? So we know S and T are the raw data we've got. Right? So if you want to plot some graphs, what kind of graph you can have? Remember, in this formula, the independent variable is X. The dependent variable is T. That's what experiment was about. So if we change the terms, then you will have T squared, which is Y, okay, equals 2 times S over A because U is 0, right? So that two possibility. One is if you put T equals Y, S equals X, then you have Y squared equal 2 over A times X. So this is it looks like a nonlinear relationship. Why this is nonlinear? Because if we put Y equals, okay, then you need to take square root on everything on the right hand side. So it's a relationship between Y and square root of X. It's not linear, it's nonlinear. So can we use nonlinear relationship? You can, but you can't do further analysis. So you can still show the nonlinear graph in your analysis, but that shouldn't be the one for you to do the in-depth analysis. So let's think about the other possibility. In that case, I'm going to put t squared equals y, s equals x. So how about that? I put t squared equals y. Remember this? Then you will have y equals 2 over ax. Okay, so obviously, and this is linear. And this one is more important than the other one. Okay, so this one is more important. So we are going to do in-depth analysis based on this. And for the nonlinear one, we might just show the graph. All right, so now we've got the kind of graph you're looking for. You're looking for a t versus s graph and also a t square versus s graph. Okay, so how can we do this in Excel? So now I'm going to turn to Excel. Remember the data here. So when I go to the Excel, I've input all the data this group has got. Sorry. Okay. So they've got displacement, they've got some 3 trials, but how about the average T? Okay, of course, they've calculated the average T, but we want to do it in Excel. I'm going to show you how can we do it in Excel. For the average, you can do it, you can do it automatically in Excel by doing, you just press equal, right? Then you enter AV. Okay, then you see an average there, so you choose this one. Okay, then they are going to ask you what numbers are you going to choose, and you can press control. Remember, press control. While you are pressing the control, you just select the numbers. So remember we're going to find the average of the three trials. So that's what you're going to do from B3 to D3. Is that okay? All right, then you will have 0, 0.7, 0.70. So when we go back here, you can see actually it's correct. Okay, and so how do I need to do that for each of them? No, you can just control and you just drag the cell downwards, and the Excel they will use artificial intelligence to show you all the numbers, and you can compare with the numbers this group got in their experiments, so they are the same, right? But we just let the Excel to do the auto calculation for us. All right, so these are the raw data. These are all the raw data. That means the data is strictly from the experiments. We have displacement, we have the average time. All right, so and next I'm going to show you how can you show that in a nonlinear graph. So let's try to select them, and then you're going to select the average time because you are going to do a displacement versus average time, right? So you need to press Control and then you select them. You need to press Control and then you select another column. All right. Then you go to the chart. So you see there are many charts here, but we are going to use scatter plot. You see that insert scatter. You press this one, so and you get this one to use. Okay, the first one. All right, and then you will see a graph showing all the data. Right. So let's change the title first. The title should be, in that case, is displacement versus time. No, sorry, should be time versus displacement, because normally we will get the y-axis, the dependent variable on the left hand side, right? And sometimes you want to add the axis titles as well. So, and this one should be displacement. So I might just use S. The unit is meter. And for this one, I'm going to use time, and the unit is second. All right. So you got the graph. So it looks like a linear, but we know it shouldn't be linear. Why? Because if that's time versus displacement. So let's go back to our previous work. So if that's time versus displacement, it should be nonlinear. It should be somewhere like this one. Okay, sorry. Remember that one, if you replace y as t and you replace your x as x, so it should be a t versus square root of x. So it should be nonlinear. Okay. So how can we get the Excel to get a approximate model for us? Right, so you can go to the trend line. So the trend line. Okay, and you go to more options. So it's the trend line. Okay, so then you automatically you will show you a linear, but we are not going to use the default one. So that's something for you to choose from. Can you click trend line options, trend line options? All right, then you see there are plenty of trend here, because we see that that's a square root thing. So you better use power, and you will try to get the equation there, and you will get a linear. All right, and okay, so you can see the power here. And let me, okay, so might be, can we make it larger? Yeah. Ooh, that's it. That's large. Okay, so possibly you can see that. So the y, right now we can change that y equals t, x is actually a s, right? So you can see the power is about 0.6, and the r square value is very high. So that actually means it's really something like a nonlinear one, because the r square value is very close to 1. But it's not exactly what we expect, because we expect that square roots. So remember, the square roots should be of the power 0.5. Okay, so the power is 0.6, so it's not too bad, but it's not what we expect, right? And so that just show you the nonlinear. You can include this one in your assignments, but we're not going to do in-depth calculation on this one, because they are just not nonlinear ones, are not that easy to analyze. So let's think about the in-depth analysis, and we want to do t-square for y. So that means you can't just rely on your raw data. You have to modify your raw data a little bit. For example, the t, you have to modify them into t-square. So how can we do that? Let's go back to our table. So for example, here, I create another column here, so you can see, let me use red line. So that means right now it's time square. So it's no longer time, it's time square. Okay, and I just need to square each of those values. For example, there's 12, so what I'm going to do here, all I need to do is equal, and then I just select this value, so you can see the B3 is being highlighted. Then I'm going to make a square. So that will be the square of that B3, so that number. Okay, you can track whether that's true by using your calculator. Okay, and how about, let me drag this down, and the AI will help you to get all the values automatically, and you can track whether they are true. Like this one is actually B4 square. B4 is this one. So if you click in, so you can see that's this number square. So that means it's correct. Okay. So similarly, if I highlight this number, I go to the right, and that number will be C3 square, and etc. So I'm not going to I don't need to do it one by one. I just copy that format and let the Excel to guess. So most of the time they will get you right, but sometimes they still need to check. So, and then these are 3 trials for the time square value for 3 trials, but we are going to find the average. Okay, how can we find the average for all those t-square value? Okay, remember the average? I'm going to do it again. So average, so it's the average. Okay, and then you have to control, you select the values. Oh, I got it wrong. You see somewhere wrong. Okay, so I should just use the free trial values. And okay, so, and you can, again, you can use your calculator to track whether it's true. It should be okay, right? Then you got all the average of t-square value for 5 displacement. Right, the next thing is, because we're going to do in-depth analysis on that t-square value, so you are going to find the uncertainty. For the uncertainty, we use AUM, absolute uncertainty mean of t-square. Still remember that AUM, okay, the formula for AUM. All right, so just a reminder. So AUM just equals your maximum data, take away your minimum data, divided by 2. Okay. All right. And okay, how can we do that? So remember, you need to find your maximum minimum data from this phrase. So the maximum is 0.55, the minimum is 0.4. So you take away and divide by 2. So you can do it manually, but again, we can ask the Excel to help us. Okay, first I'm going to have a bracket, so I'm going to find the maximum value. So actually that's such a function called maximum function. And maximum, that's what I'm going to select. And then you have to get a group of number among which you can find the maximum value. So I'm going to get the maximum value for my 12.1 to 12.3. So all this value I'm going to select. Okay, all right. So, and then I'm going to do a minimum. All right, sorry, minimum. So actually that's a minimum. Again, I'm going to use my F3 to H3 again. All right, and the whole thing I double bracket divided by 2. Then you will have your AUM. So your AUM is 0.08 for this one. Does it make sense? Okay, so let's try to do it manually. So if you can get 0.55, take away 0.4, that would be 0.15. Then you divide it by 2. And divided by 2 is 0. Okay, 0.075. But since we correct that to 2 decimal places, it becomes 0.08. All right, and also if you drag this down, so every time they would just do it automatically. Okay, so you see the AUM difference for some of the for some displacement they are smaller, like the smallest could be 0.06, but there are some are bigger. All right, so you got the AUM, which would be useful for our error bar analysis. All right, so and what would be the next? Yes, then we are going to plot a graph. Remember, for the in-depth analysis, we're going to plot a graph using t-square versus s. All right, that should be linear. So, but let's see. So t-square versus, so I'm going to get the displacement. That should be my x value, and the t-square value, that should be my y value. Right, then I'm going to insert that scalar plot again. Oh, sorry, something wrong. So let me, sometimes could be tricky. All right, okay, let's select that again. Possibly some mistakes there. Let me select these two. Yeah, this time it works. Okay. Okay, so then I'm going to change the chart title. The chart title is time square. Okay, square of time versus displacement. All right, and I'm going to do the axis title as well. Okay, so this is our displacement and with unit meter, and this is our square of t. So let's make it t square. The unit is second square. Wait a minute. Oops. Right. Good. Right. And let's focus on that graph. Yep. So it looks like linear to me, but we still need to see. So we're going to do trend line. Okay, in trend line, again, you click in, you go to more options, and then you select the trend line options. Then you see linear. All right, so we are going to use linear because we expect that's a linear. Then you ask it to display equation. and that's linear, and also display your R square value. So R square value is quite good. It's 0.9.873, so it's nearly 0.99. So for an experiment, that means this group did well. And right, so but of course you would like to change those symbols, and you are going to change that as t square. Oops, I change the x first. So s is a s, displacement y is a t square. Yeah, and so this is a function. But the next thing is, for the linear graph, we really need to do the error bar. Okay, the error bar, because without the error bar, there's no uncertainty analysis. Also, you can't plot the line with maximum slope and the least slope. So that's what I'm going to do. I'm going to create the error bar. All right, so you go to the options here, and you can select error bar. So the default error bar, they're default. You have to change them. So let's go to the options here. So you can click the error bar, asking for more options. Then you see the error bar option. So it start with, so click that error bar options, start with X error bars. So X error bars is just the error bar for displacement. All right. So, and you need to think about what would be the uncertainty for displacement. Okay, let's go to the error bar options here. So we're going to use both sides error bar, and the uncertainty for displacement should be fixed value, because every time you use a ruler to measure the length of the displacement. Okay, so the standard error for using the ruler should be 0.01. Okay, but if you are more conservative, you think about like, well, it's not a flat surface when you draw those lines, so we might double the uncertainty, which becomes 0.02 meter, which means let's see, that's 1 meter. So it should be, so the standard uncertainty should be 1 millimeter, right? So, and we'll make it 2 millimeter, so that should be 0.02. So it's very small number. You can see that's very small. Okay, and but that's okay. If you think your measurement of displacement is quite good, then that's it. So that means there's not much uncertainty in displacement. Right, but how about more options here? Yep, so let's go to the error bar of y, which is t square. Okay, so for t square, the error bar is trickier, because for t square, we're going to use the AUM. Okay, but AUM values are all different for each displacement. For example, for the first displacement, the AUM is only 0.08, but for second, 0. How can we introduce, how can we impose those varying uncertainty onto our vertical error bar? So, and for doing that, so you see you can use fixed value, which is used for the horizontal axis, which for displacement just 0.002, but not the percentage, not standard deviation, not standard error. So we're going to use custom. Okay, custom, that means you are going to input a specific value. All right, so watch carefully here now. Then you click that specific value. All right, so they will show you the positive error bar, negative. That means the upside, the upper part or the lower part. So we are going to use the same value for both parts. Okay, so you just press your control and you select all your AUM values for the positive part, and then you go to the negative part, do the same thing again. All right. Oh, yeah, I know what happens because that's it's annoying. Oh, sorry. Let me do it again. Sorry. Okay, so I'm going to do it this way. Okay, and hopefully this time will be successful. Oh, it's not. So let me do it again. Okay. Yeah, there we do it. So, okay, and I do the correct thing. Oh, I might select the wrong thing. Sorry. Oh, sorry. Um, sorry. I think is that correct? Not sure. I better do it again because I'm really worried that I make a mistake here. So positive error bar, I just select all the, oh, I know what happens. I just select all the values here, from here to here. Okay, that's for all for negative error bar. I'm going to do the same thing. Yeah, I think that's correct. And you can see that for the vertical error bar, some is shorter, some is much um, is much longer, right? And so that's correct because you will have different error bars, all right, and that's quite natural. And so that's how can we create the error bar. So basically you present your data um, nearly everything, but you still need to do two lines, the maximum line, maximum gradient line and the minimum gradient line, which I've shown you in another Excel file. So I'm going to do that in next video. All right. Okay. See you next time. Bye.